Today, we want to learn really how to write functions in algebra class and the difference between kind of the elementary way to write a function and a more advanced way to write a function called function notation. So write down the goal. The goal for today is to be able to use function notation. And let's look back at kind of the elementary way to write a function. When you first start learning functions, and whatever grade you learn them in, typically you would write them, I call it the elementary way. It might look something like this. Y equals 5x plus 1. This is a basic way to write a function. And here's a command. Find y when x is equal to 2. Well, here we could plug 2 in for x. 5 times 2 is 10. 10 plus 11 is 21. So in this case, the 2 would be called the input of this function, and the 21 would be called the output. And I could go on and on. There's many inputs and outputs that would go with this function. I can make a long table. I could draw it out on a graph, all the inputs and outputs to this function. It ends up being a linear relationship. It would make a straight line. But this is the elementary way to write a function. Now, as you advance along in algebra class and get to more advanced levels, you start to learn, I'm going to call it the collegiate way to write a function. This is called function notation. Now, this is actually pronounced, this looks like it could be like an f times x, but it's actually pronounced f of x equals 5x plus 11, and the command says find f of 2. With function notation, there's a rule that the input, whatever you're asked to input into the function, is always placed inside parentheses right next to this letter f. And then our output would be the same, okay? F of 2 would be equal to 21. 21 would still be the output. But the key is that with function notation, we always put our input inside of the parentheses, and then our output would be our answer, whatever answer we get as a result. And you also need to realize how this is pronounced again. This is pronounced f of x. This would be pronounced f of 2. Now, there's many advantages, in my opinion, of being able to write a function using function notation as opposed to the older elementary way. But I think the biggest one is naming functions. Imagine if you're working out a problem that has 3 different functions. Well, under the old way of writing functions, the elementary way, every one of these functions would have the same name. They'd all be called y equals. It's like you would have the first y, and the second y, and the third y. Now, you could use subscripts. Some people would call this like y1, and y2, and y3. But still, every one of these functions is named y, and it gets a little bit confusing to try to distinguish between the first y and the second y and the third y. A major advantage of function notation is that with function notation, you don't have to use the letter f every time. You can give each function a unique name. Here we have a function f, a function g, and a function h. Each function has a unique name, and it's just a little bit easier to name when you're comparing different functions.
For the last half of today's lesson, let's take those functions we just looked at, f, g, and h. Let's work out a few examples. So let's start simply. Example number 1, find h of 7 plus g of 4. All that means is I'm going to take the number 7, this input of 7, I'm going to input it into the function called h. Everywhere I see an x, I'm going to replace it with a 7. And I like to work these out separately. Okay, so if we do 49 plus 7 plus 3, that ends up being 59. Feel free to use a calculator if you want to. Okay, now I'm going to take 4 and plug it into the function g, meaning I'm going to take away this x, replace it with a 4. 9 times 4 plus 4. I'm going to work this out separately. 9 times 4 plus 4 ends up being 40. And you see the relationship here between these two functions. I'm meant to add them together. Ultimately, that means I'm going to be taking the 59. I'm going to figure this out first as 59 plus the 40. It ends up being 99. Now, the second example introduces kind of operations between functions. This is read as h minus g of 2. So this may look a little different to you. It's taking this to the next level. Another neat thing about function notation is you can easily do operations between two functions. This literally translates to find h of 2 minus g of 2. Now, I'm going to show all of my steps. I plug 2 into the function h. I input a 2 into h. That would give me 4 plus 2 plus 3. That'd give me 9. And then I'm going to do the same with the g of 2. I'm going to plug 2 into g, meaning I'm going to do 9 times 2 plus 4. That'd be 18 plus 4. That would be 22. Now, a little note here. So this means I'm supposed to subtract these two functions. And technically, if you were trying to do this all in one step, you would need to add kind of a new set of parentheses around everything. Now, as long as you kind of work out each function separately, you don't have to worry too much about parentheses. But ultimately, we have to take this 9 that we found, subtract it by this 22 that we found, and the final answer, negative 13. Now, this third problem is going to be the trickiest of the day, because you'll notice, so here I have these functions f plus g of x plus 1. Well, this is different because here our input is not simply a number. Here our input is actually this expression, x plus 1. You'll notice in our previous examples, we always had inputs that were numbers. Here was an input of 7, an input of 4, an input of 2. Those are relatively easy, can mostly be done on your calculator. How do you handle a problem, though, when your input has a variable? Well, we're still going to handle it the same way. This literally translates to f of x plus 1 plus g of x plus 1. So what that means is I have to now take this expression, x plus 1, and input it into f. In other words, I'm going to take away this x right here. I'm going to take the 3x minus 1. I'm going to take away the x, leave a hole where the x used to be, and I'm going to input in its place an x plus 1. Now I like to work these out separately, so this is not something that you can just type into your calculator because of the variable. This is something you actually need to simplify. We're going to distribute the 3. This would become a 3x plus 3. And then don't forget about the minus 1 I have here at the end. Positive 3 minus 1 is positive 2. So this f of x plus 1 simplifies to 3x plus 2 when I put the x plus 1 in place of this x. Now I need to do the same with the g of x plus 1. I am going to, in this 9x plus 4, I'm going to take away this x, and I'm going to input in its place x plus 1. Now again, I can't just type that into my calculator because of the x. I need to simplify. I'm going to distribute. This would become 9x plus 9. And don't forget about the plus 4 here. Ultimately, this becomes 9x plus 13. Now, I've worked these out separately. Now, the instructions say the operation is to add them together. I can add a 3x plus a 9x. That becomes a 12x. I can add a 2 plus a 13. That becomes a 15. Final answer, 12x plus 15. All right, you'll notice I have a check problem here. I'd like for you to try this one on your own. Pause the video right now. Give this a shot. Do g minus f of x and unpause when you're ready for the answer. So the final answer of this check problem, 6x plus 5. Now there's a couple things that will trip students up quite often. First off, how does this translate? This translates to g of x minus f of x. And so I know it's kind of weird telling yourself, hey, with g, I need to take away this x and replace it with this input of x. I know that's kind of weird because nothing changes. Basically, this g of x just stays 9x plus 4. And I'm doing the same with the f of x. In essence, I need to take away this x, but replace it with an x. Well, nothing's going to change. I'm still left here with 3x minus 1. But the reason why most students get this incorrect is because this is a subtraction problem, is because is basically with parentheses, okay? If we're ever asked to subtract two expressions from each other, 9x plus 4 minus 3x minus 1, you almost have to think of it as distributing this minus sign. So here, when I combine the 9x minus the 3x, I get 6x, and most students get that right. But when I do the 4 minus the negative 1, this is actually the same as 4 plus 1. Remember, when you subtract a negative number, it's the same as adding that number. So this is the same as 4 plus 1. It becomes a positive 5. So I highly recommend when you're, if you ever have to subtract two functions like this, put parentheses around them, work them out separately, put parentheses around those answers, and then if you subtract, remember to distribute that subtraction sign. All right, best of luck on your assignment. As always, let me know if you need any help.